Hello, my name is Kent Trammell, and I want to welcome you to another installment of Blender Cookie's Shaderforge series, where we are taking an in-depth look at complex node materials for cycles. In this video, the material type is brushed metal. This is a common surface finish that you see a lot in architectural visualization and product rendering, where the key characteristic is a phenomenon known as anisotropy, and this is basically a fancy term for reflections that seem to stretch across an object. So here in Blender 2.7, we're going to start with the same shader totem object that we used in the first Shaderforge video, and we'll continue to use for all of them. We have a default light setup, along with a camera that makes rendering very simple. Down here in the bottom right, you can see the perspective from our camera, and we're using the Cycles render engine. I'll create a new material while having our shader geo selected, and I'll hit Shift-Z in this bottom right viewport to see what the default render looks like. And now we're ready to begin building our shader. I'll go ahead and rename this Metal Brushed. And actually, before I jump into the node editor, I want to open a few reference images for us to study so we're pointed in the right direction. Let's go grab these guys out of my ref folder. Brushed Metal 1, 2, and 3. Which only opened Brush Metal 01, so let me go grab the others. Okay, we'll start with Brush Metal 01. The reason I have 3 reference images is as I was searching, I found out that brushed metal comes in a wide variety of surface qualities, so by referencing 3 different images, we can get a more well-rounded shader. And this is kind of a pristine brushed metal surface where the reflections seem to stretch all the way across the object like this. We can see one there and see one here, as opposed to standard reflections which concentrate the reflections exactly the way they appear in the environment that it's reflecting. But here the stretching effect is called anisotropy, and it can be attributed to the very, very fine abrasions in the surface that we can see. They're very tiny, subtle scratches that cover virtually the entire surface, and they're very uniform. As we look over the entire surface, you can see that these fine abrasions exist, and they're actually causing that stretching effect. I'll go ahead and get rid of that grease pencil layer. And if we look at brushed metal reference image number 2, this is more of a straightforward view, like a texture almost. And we can see in here the very fine abrasions that are consistently running from the top of the image to the bottom of the image. We can see those, again, across the entire surface. But on top of that, we have very random scratches that come from all different directions, all different orientations. And this produces more of a worn and torn, imperfect type of brushed metal. And then in our third reference image, this is the top of an aluminum can. And to me, this represents kind of a mix of the first 2 images, where clearly we can see the uniform microabrasions that give us our anisotropic effect. And if we look closely, we can also see some very subtle scratches on top of the microabrasions, like right here, that break up the reflections and give it a slightly more imperfect variety to its surface. So ultimately, this is the kind of look that I want to end up with. So I will get rid of that grease pencil mark, and I will split my UV image editor in half. And in the bottom, let's switch over to the node editor, where we have our default diffuse to material output node that comes standard when you create a new material. And this shader construction process is basically going to be 3 steps. First, we will implement the anisotropic BSDF that approximates the anisotropy phenomenon. And then on top of that, we will introduce the uniform microabrasions. Then finally, the last layer will be these subtle scratches to break up the uniform reflections. So for the first step, it's going to be best to look at our first reference image and go ahead and add the shader anisotropic BSDF. And I'll go ahead and delete our diffuse and plug up the anisotropic so we can see what that looks like by default, and Blender crashed. So let's see if I can't recover that by going to File, let's see, Recover Autosave, and I believe this is the most recent. Yeah, okay. So let me just repeat this. Something I've noticed about dealing with really complex node materials is Blender will crash more frequently. And maybe it's just because I have viewport rendering down here in the bottom right, but I use that all the time. And this is by far the most it's crashed when I deal with these complex materials. So let's get back to where I was. Anisotropic BSDF, and get rid of my diffuse. And go ahead and save this file. And now Shift-Z in this bottom right viewport. I'll just try to save very frequently in case it crashes again, and that's very likely. Okay, so just by adding the anisotropic BSDF, we immediately get those stretched reflections. If we look in here at the preview, you can see how the reflections stretch from top to bottom. And the way that we can judge this is the anisotropy option right here is set to 0.5 by default. If we change that to 0, we essentially get a regular glossy shader. There's absolutely no stretching, and the reflection of the light here is round and uniform. But as we begin to increase this value, let's go to 0.5, which is the default. You can see how it stretches, and then as we go up, let's say 0.9, it stretches really, really far. And that's a little bit too extreme, so I think about 0.5 or 0.6, well, maybe 0.7. I think that's going to be a good value to start with, because looking at our reference image, let's go back to the first one, you can see how far the reflections stretch, literally across the entire surface that we see. So a value of 0.7 will be good. And honestly, this can be your entire brush metal shader for objects that are kind of far away. But if we zoom in closely, you can see that there's no abrasions or any kind of scratching being introduced by this shader. It's merely an approximated effect designed to generalize the anisotropic phenomenon. So this BSDF type is stage 1. For stage 2, I want to implement the micro abrasions that we see uniformly across the surface of brushed metal. And so let's save before it crashes, just in case it crashes. And now I want to add a texture, noise texture, and also add an input texture coordinate node. And then actually after that, a vector mapping node. And I'll get these situated and then explain what I'm doing here. So the goal here is to create a completely procedural texture map that will influence the roughness value and also the color value of our anisotropic BSDF. So for now, I simply want to concentrate on the texture itself, not how it will affect my shader node. And in order to do this, I usually add an emission node and plug that texture directly in, and the emission node into the surface. Well, since the last Shaderforge video, I've begun using the Node Wrangler add-on here, or it's also called Node Efficiency Tools. And what this allows me to do is Shift-Control-Click on any node, and it will plug it directly into what they label as the viewer node. It's essentially an emission node. And automatically that's plugged into the surface. So with one click, I can see directly the output of any node. And if I Shift-Control-Click again on that same node, it'll cycle through the outputs. So in order to enable this, which comes with Blender by default, simply go to the Add-ons panel in the Blender User Preferences and type in Wrangler. And you'll see Node Wrangler, and you can enable that and have that same functionality. Now, back to the noise texture node. What I want to use this for is the micro abrasions we see in the surface. So this texture is good for that only after it's stretched, which we can do with the mapping node here. So from texture coordinate, let's plug in our generated coordinates into the vector of our mapping node. And since this is a procedural method, I generally always use generated. Then plug in the output vector into the vector of our noise texture. And doing that will change nothing because everything's set to default and the noise texture uses this setup already by default. But now that I've added the actual nodes, I have access to location, rotation, and scale. Scale is where I'm going to be able to stretch out this texture. So first, let's switch over to the texture option up top instead of the default point. And now in our scale options for X, let's make that 30. And then Z, let's also make 30. Now if we look at our real-time render feedback, we can see that the texture is stretched, but in general, it's way too large, and that comes in for the scale option of the noise texture. We need to increase this significantly to make our noise texture really, really small. So I'm going to bump this up to 400. And now when I do that, you can see just how fine all of these color variations become. And because they're stretched so much in the X and Z axis, but not in the Y axis, it starts to look like those microabrasions. And now we have a black and white factor that we can plug into our anisotropic BSDF. So after the noise texture, I actually want to further adjust these colors with a converter color ramp node. By default, nothing's changed when it's plugged in, but if I drag up these flags, now I can introduce some contrast with brighter brights and darker darks. So now the scratches become a little bit more apparent, a little more defined from one another. Again, the whole goal during this process is to make this texture mimic what we see in our reference image up here. And now if I plug in this output, this texture output, into our roughness value of the anisotropic BSDF, let's see what that does, saving our file first just in case it crashes. And again, with the node wrangler enabled, I can shift control click on this anisotropic BSDF, and it will automatically remove that viewer node and plug this directly into the surface output. And now in our render viewport, we can start to see the effect that this has on our anisotropic shader. We're getting the micro abrasions, but the values are in general way too extreme. So remember, if we plug in a white value into the roughness, that means it's a value of 1. And a roughness value of 1 basically makes it a diffuse shader. We don't want the reflections to be that diffused or that blurry. So we need to adjust these flags here, because also with black, we don't want any of it to be perfectly reflective. Instead, I'll select the black flag and change that value to 0.05 in the HSV, specifically the V slot, 0.05. And then in our white flag, let's change that to a value of 0.2. Now take a look at our render output. And now we're still maintaining the general sense of reflections. But if we look closely, we can see how this noise texture is affecting the surface. It's introducing those very fine micro abrasions. Let's zoom in here just so you can see for sure what's going on. Let that clean up. Here we can really see the effect. But I can also accentuate this a little bit more by not only plugging it into the roughness socket, but also to the color of the shader node. So let's save the file real quick and then shift control duplicate this color ramp node. And we'll just move it below. And this one, or actually I'll move it above just to make more visual sense. This one will be plugged into our color slot. And the values for these flags, let's see, the darker one will be 0.3, and then the lighter one will be a full value of 1. This will result in a very subtle change, but it is still noticeable if we zoom in. It's just offsetting the color to make these micro abrasions pop out a little bit more. So now that I've zoomed in, keep an eye on it as I plug this into the color value. You should see them start to stand out more, and it should begin to look a little bit like our reference image, ideally. Let's zoom out now and kind of get an idea of the shader as a whole. Maybe make our render viewport a little bit bigger. Yeah, that's looking a lot nicer. It's really lending itself to the brushed metal feel, but still this looks a little bit too perfect, like a pristine brushed metal, and I want to break that up a little bit more. But let's see, I'm going to take another look at our noise texture by itself by shift control clicking on the noise texture, and that will switch it back to the viewer node. And I'm going to play with the orientation of our texture node with the rotation options. Specifically in the Z-axis, I'm going to switch that to a value of 30, and that slightly offsets the rotation to be, yeah, just a little bit more interesting and with a little bit more variety. Yeah, I think that looks nice. And that is all for stage 2 of this process. Stage 3 is by far the most complex. Well, it's going to look complex, but it's actually a simple set of nodes that is repeated over and over to achieve the surface scratches that we especially see in our other reference images. Let's look at number 2. Here we can see them very prominently, and so I can look at this to reference the pattern and how random it is. But what's interesting about these scratches is though they're oriented all different directions, for the most part, they're still straight lines. Like here, this scratch is a straight line, straight line, straight line, straight line. They're just crisscrossed from all different directions. And even though we could achieve this pretty easily by using an image texture, again, that's not my purpose with this series, because ideally I'll be able to show you how to create everything in the shader procedurally. And while that might not make sense, you might be thinking just plug in a texture and be done with it. If you continue watching these videos, I think you'll see just how versatile procedural methods can be and how valuable they are for your personal skill set. So for the third and last component of this shader, I'm going to duplicate the mapping and noise texture node here with Shift-Control-D. And let's just move this down out of the way. And Shift-Control-Click on our noise texture because we will be focusing specifically on the black and white values. And to address that, let's add another, converter color ramp node. And similar to the idea we used initially for these micro abrasions where we stretched out the noise texture, we're going to push that further to achieve scratches because, again, these scratches up here from the reference are basically straight lines. So instead of a value of 30, let's bump that up to a value of 200 in the X as well as 200 in the Y. Not the Y, the Z. So when we look at our shader now, our lines should be a lot straighter. And if I come over here to the rotation values, let's switch all of them to be 45. Now the lines of our noise texture are very straight and crossing the entire object. So this is awesome. We can use these grayscale values now by adjusting them with the color ramp to define our scratches further. And I will drag each of our flags really close to one another, but a little bit closer to the dark side of our ramp. And right away you can see how we're starting to get some black lines, which when plugged into a bump map will be like the scratches we see in our reference. But I can get those flags even closer to fine-tune our scratch width. And let's see, I can push that even further by increasing the scale of our noise texture from 400 to 600. Yeah, that makes it very, very fine. Yeah, and so this is what our scratches texture will essentially be. But the biggest problem with this is all of my scratches run in one direction, whereas, again, based on our reference, they should be coming from all different directions, crisscrossing one another across the entire surface. So instead of achieving this with just one set of scratch nodes, these 3 nodes right here, I can simply duplicate these 3 nodes with Shift-Control-D to maintain the incoming texture coordinate, and then come into the mapping node and reorient my scratches into a different direction. Then I can mix this new set of scratches with the old set of scratches with a color mix RGB node. Plug in the first one to the top color socket and the next one into the bottom color socket, factor up to 1, and the operation to multiply. Now Shift-Control-Clicking on this node won't look any different in the viewport because these are straight duplicates and I haven't reoriented my texture coordinates at all. So this time let's make the X rotation value -60, the Y rotation value -20, and then the Z value 30. Now if we look at those by themselves, we can see how these are now facing the opposite diagonal direction as the first set. So when we mix those together, we get some nice crisscrossing scratches. But going back to the mapping node and the rotation values, where did I get those? Well, obviously I've explored this and know which values will give me the desired result, but the mapping node I don't really know the science or the math behind it. So for me, it's just a lot of experimentation. And if I focus in on this second set of scratches, I believe that the rotation respects the axes that we see here in the bottom left corner of our viewport. You can see Z is pointing up and down, Y is front to back, and X is right to left. So based on this, I think that I can adjust my Z value. Let's go to 90, and my scratches will rotate around my object in this direction. And the same goes for these other values according to their respective axis. But even when I attempt to understand exactly what's happening, I always resort to experimentation. So that's what you'll have to do to figure out which values work best. But the mapping node is extremely powerful when it comes to procedural textures. I'll set this back to 30 and then plug up our mixture one more time to the viewer node. Control S to save. And now I'm going to repeat this process 3 more times so that I have a wide variety of scratches and directions. Selecting now all 4 nodes, Shift Control D, and let's move that down. And for this new multiply node, I'll simply plug in the output of our first multiply node into the first color swatch. Now take a look at that in the viewer node. And we shouldn't see any difference, but at least it's set up so I can see the difference when I plug in new rotational values. And for this one, I'll show you kind of my process for figuring out a good direction. I'll switch all of their values to 0. And let's see, just take a look at this color ramp alone. Up until this point, I have 2 set of scratch nodes that produces kind of an X pattern of scratches all across the surface. Now I want one that goes straight up and down. So let's see if at the default rotation of 0 and 0 for X and Y, what if I switch the Z direction to 90? And yeah, there we go. This gives me some scratches that go from top to bottom. That's simple enough. Take a look at the mixture. And we're gradually starting to build up a nice randomly oriented set of surface scratches. So let's do it one more time. Shift Control D and fix our multiply node. Or not fix it, but set up the mixture properly. And this time, let's see, what orientations are left? We've got top to bottom, we've got the X pattern, so how about horizontally? Let's change the Z rotation back to 0, and I need to see this output directly. Okay, that actually looks pretty cool with all of them set to 0. The scratches kind of follow the curvature of my object, so I think I'll use that in the next set of duplicate scratches. But for this one, if I change the X value to 90, this gives me those horizontal scratches that I want to mix in. So let's look at the mixture. That's filling up quite nicely. And now duplicate one more time, returning my mapping values all to 0. Then multiply this properly over my other scratches. There we go. Now we have the main directions set up for scratches, and the overall effect is very random, which is what I'm looking for. The only problem with this is the scratches very uniformly cover the entire object. It would be more realistic if that effect is more random. So some spots have a lot of scratches, some spots don't have a lot of scratches, which I can easily implement with a noise texture, this time by itself without any mapping node plugged into it. Let's save my file and take a look at this by itself again. So let's see. Looking at the factor output, which is black and white, my scale is way too small. Let's bump this back up to 5. And this is more of the default, actually 5 is the default value, which is what I'm looking for to introduce some of the randomization of the scratches. And let's add another converter color ramp node after the noise, just to give me some additional control. And with this, I will introduce some significant contrast. There we go. And with this black and white output, if I add it to the output that we have already with our scratches, then whatever you see black right now, that's where the scratches will be the strongest. And wherever it's white, that's where the scratches will be the most subtle, if they're there at all. So let's duplicate our Mix RGB node. I'll just do Shift D this time. Change the operation to add. Drag in our scratch output to the first color input, and then this new noise texture output into the second color swatch. And save our file, Control Shift click on this add node. And now if we take a look around, our scratches are much more random, where up here at the top, they're very strong, but then over here at the side, they're not quite so strong, they're a little more subtle, and all the way around, we can see more of a randomized scratching pattern. And now this is what we can plug into a bump map. I know that seems like a lot of work, and when you zoom out, it seems complex, but it's actually very simple. And most importantly, we have a very finely tuned texture map without using a single image texture node. And it's scalable, it's not limited to the pixel data, which is pretty cool stuff. So let's select these bottom nodes and kind of move it off to the left, just so that our noodles aren't quite so extreme, kind of make a less visually obnoxious network. And now we can add a vector bump map node, which will come after this addition mix node that we have down here. Though instead of plugging it into the normal value, we want it into the height value. And you'll start to get a very funky rainbow effect. That's because this bump map, which is a normal vector output, is being plugged into a color slot. So we'll actually plug this into the normal socket of our anisotropic BSDF. And zoom in here, make sure you don't plug it in the tangent. That will not give you the desired effect. And now I'll save my file and Shift-Control click on this anisotropic shader node to plug that into the surface output. And right away, just from experience, I know that the default strength of our bump node, which is 1, is just crazy powerful. And we need to bump that way down to 0.1. And now let's zoom in to see the effect. Your shader will be fairly slow at this point. I find that the anisotropic BSDF does take a while to compute the reflections, but in my opinion, that's definitely worth it. Okay, so we can see that we're getting the scratches, but we're also getting an artifact that kind of makes the surface look bumpy, almost like hammered metal. And the reason for that is with this addition node, our values, because I added my noise texture over top of this multiply that was already black and white, when you have a value of 1 that comes from the white values in this multiply node, and then you also have white values from this noise texture node, so that's a value of 1 as well, add 1 plus 1, it's a value of 2. But I don't want it to work like that. I want the addition of white to basically cancel out those black scratches. So if I change this, or rather enable this clamp value, that means that the values are clamped at 0 and clamped at 1. So now we will just get these scratches and we won't get that effect of the noise in the bump. And now as the render starts to clean up, we can very clearly see those scratches. And they're working great, exactly how we want them to, but perhaps they're a little bit too strong. But first, I want to see how this renders fully by itself. So up here in the render menu, render image. Okay, that's actually looking pretty good. Though I think, again, that these scratches are a little bit too strong. And also one of them is creating a pretty weird circle artifact right in the center of our shader. So let's switch to slot 2 and decrease my bump strength. Let's go to 0.075. And then also see if I can't figure out which scratch texture is giving us that kind of weird artifact. Okay, so it's this last one. Let me try decreasing the scale. Let's try 500. Okay, what about 400? There we go. Yeah, that's much better. Okay, now it's completely gone, and let's see. Plug up our proper shader into the surface output, And I think that makes the shader complete. Well, let's give it a render to see. Okay, I think this is looking pretty good. Let's compare it to the first render with Alt-J. Here the scratches are a little too deep. I think making them more subtle lends itself positively to the overall feel of the shader. And especially up top here, it's pretty much exactly what I was going for. But at the bottom, I think due to the geometry, the scratches, especially here, seem to be a little bit too deep. But because they look good up here, I'm going to trust that the shader is set up properly. Just the geometry and the automatic texture coordinates that have been generated procedurally, I think kind of hinder the scratching effect, as well as these microabrasions due to the geometry's shape. They kind of conform and morph around, which isn't ideal, but the true test of the shader's versatility is to apply it to an object that would usually be brushed metal. So I've done this already and rendered a toaster from Blend Swap. Let's go find that image. This model is by Printer Killer, and I think the shader holds up pretty well when applied. Though there's certainly more that you can do to push this shader further. You could convert the complex network that we've created into a node group for easier, more straightforward manipulation. For example, it would be great if I could control all of the scale values of my noise nodes relative to one another with a single input value. And also, as kind of a challenge, you should know I usually implement a Fresnel component anytime I deal with reflections, but I didn't do that here. Therefore, my challenge to you is to study reference images and figure out the best way that Fresnel should be implemented here. If you choose to accept it, please post your results in the image gallery or throw out suggestions in the comments. That's going to be all for this video. Thank you for watching.